this is our case 2, where again we have to find the center of mass of compound rigid bodies, but when some area is removed from the entire body, so some area or some part is missing. So in this case, basically you treat the masses, the part which has been removed, you treat that as a negative mass. So here the same formulas can be applied, but rather than positive M2, we are replacing that with minus M2. So the cavity will be treated as a negative mass, and here also it would be M1 plus M2, but rather than this, we are going to use minus M2, right? So the formula is going to be this. If you want to treat in terms of area, then you can go with A1 R1 minus A2 R2. What is A2? A2 is the area of the cavity. And what is R2? R2 is the center of mass of the cavity. What about M2 and minus M2? So basically cavity is treated as a negative mass. So M2 is mass of the cavity. And what about M1? M1 is the mass of entire thing before we remove the cavity. Same thing can be applied for all the X, Y and Z coordinates separately if you want to get. So all the things like the formula for position of center of mass, if it is treated as a, like if it is split in all 3 separate components, then we get these formulas. So separate formula for X, Y and Z can be applied. If it is symmetric about X, then just get the X coordinate. It will be basically, if it is symmetric about X axis, then just get the X coordinate. YCM and ZCM are going to be 0. Let us have a look at a question. So this is a question. We need to find the position of center of mass of the lamina, which is shown in the figure. So lamina is basically this much. It was a circle. It was a disc of radius A, but we removed the another disc. Part of it has been removed, and which is having a radius of A by 2, right? So now we need to get the center of mass of this cavity. So first is, I am treating as 2 different objects. One is, this can be treated as one full disc plus this small disc, where mass of this is like M1 and mass of this is like negative M2. So now let us write the mass. So let us consider that here the density and thickness is basically, formula for mass is calculation is density into volume. Volume is area into thickness. So let us say that rho and T, that is, I am considering it sigma. It is sigma into A. So this is the mass. What is M1? M1 is sigma into A. What is the A? A is the area of this, which is having A radius. So area is pi A square. Similarly, what about M2? M2 is going to be negative. The same sigma, but the radius is going to be A by 2. So it is pi A by 2 whole square, pi R square, minus sigma pi A square by 4. This is going to be my M2. Now let us apply the formula. What is the formula? Here this is symmetric again about x-axis. We just need to get XCM. YCM and ZCM are going to be 0, 0. So let us get XCM. It is M1 X1 plus M2 X2 divided by M1 plus M2. Since this is a cavity, I am going to make my second mass negative. So what is M1? Sigma pi A square. What is X1? Center of mass of M1. So this center of mass lie over or at the origin. So it is 0, 0. So X1 is 0. Plus M2. M2 is basically negative mass. So I am writing minus sigma pi A square by 4 into X2. What is the center of mass of this disc? So if this is the only disc, then center of mass lies of this cavity lies over here, which is having a X coordinate as A by 2. So A by 2 divided by M1 plus M2. So sigma pi A square minus sigma pi A square by 4. Your M2 is negative over here. And when you solve it, basically in this case, all the sigma pi A square terms are gone. You are left with minus A by 8 over 1 minus 1/4, that is 3/4. So this cancels it too and we get minus A by 6. Why minus a by 6? So minus a by 6 means where? Somewhere over here. So center of mass of this entire disk after removing cavity lie at a distance of a by 6, other way around because it is negative, from the center. And were we expecting this? Yes, we were expecting this, because when you remove mass from here, the center of mass goes away from, like initially it was at center. When you remove this mass, center of mass lie toward a larger mass. What if you add some mass over there? If you add, then it should shift towards right. So similarly, when you remove something, it should shift towards left.